Example G, we have a diagram which consists of a large triangle, and inside the large triangle we have a smaller triangle. We've got an angle of 30 degrees inside the smaller triangle here, and we've got an angle A in the bottom left corner. You'll also notice that within the smaller triangle that two of its sides have the same number of dashes, and that tells us that two of its sides are the same. That's also going to tell us that it's an isosceles triangle, which means that two of its angles are the same. So to get the two angles that are the same, remember you always look for the corner where the two identical sides meet, and then it will be the other two corners that will have the same angle. So I'm just going to mark that first. So this corner and this corner are going to contain the same angle. Now our job is to work out what the angle here is in the bottom left corner, because if we know this angle, we can then get angle A by using corresponding angles. So let's go to our isosceles triangle and work out the little angle here at the bottom left. So we know that angles in a triangle add up to 180. So we're going to have to subtract 30 from 180 to get what these two remaining angles are. And then we're going to have to divide by 2 because these two angles are the same. So there's definitely more than one calculation, so we need to show our working out. So the first calculation is 180 degrees subtract 30, and that's going to give us 150. So that's what these two remaining angles are. We then have to divide 150 by 2 to get what one of these remaining angles are. So our next calculation is 150 divided by 2. So 2 doesn't go into 1, 1 carries over to make 15, 2 goes into 15 7 times with a remainder of 1, carry it over to make 10, 2 goes into 10 5 times. So we've just worked out that each of these little angles here are both 75. So it doesn't do any harm again to put those in our diagram. And now we're in a position to get angle A. So what we're going to do is we're going to draw on a suitable letter F such that angle A and this angle here are corresponding. So again, because angle A is what we want, I'm going to trace over the two lines that angle A lies between. So that's going to form part of our F, and then to complete the F we need to trace over the other line here. Like that. Now it's definitely a letter F because it contains two parallel lines, and in this situation it happens to be upside down. But you can clearly see that the angle here and the angle A there are corresponding because they lie inside the letter F. They both lie at the joints of the F, and they both lie on the same side of each parallel line. They both lie above each parallel line, so they're corresponding. So that means that A is therefore equal to 75 degrees. And again, put our reasons in brackets as to how we got our answer. So the first thing we realized was that we had an isosceles triangle up here. So I'm going to just call that IT for short. We then used angles in a triangle to get this angle in the bottom left. So that's AIT. And then we used the F rule to get angle A for corresponding angles. Okay.